With little movement on the front line, apart from limited Russian gains in pockets in the east, Ukraine's use of drones has proved a vital tool in stopping the Russians.
On the road leading to the Ukrainian city of Pokrovsk, an RFRL crew spots a Russian drone spiraling from the sky.
How is it even possible for Ukraine to carry out such a long-range attack with drones?
This is what failure looks like: a multi-million-dollar aircraft, a state-of-the-art sensor package reduced to a blind, tumbling piece of metal. This is the reality of the modern battlefield, an invisible, raging storm of electronic warfare. For decades, the drone was the undisputed king of the sky, an unblinking eye guided by invisible radio waves. But its greatest strength became its most fatal weakness. Imagine trying to whisper a secret to a friend across a screaming football stadium. That's a radio-controlled drone in what the military calls an RF-denied environment. The air itself is weaponized, flooded with so much noise that commands are lost and video feeds dissolve into a blizzard of static. The drone is deaf, dumb, and blind. For years, the solution seemed to be making the drone smarter. AI-powered autonomy, sophisticated frequency hopping, a digital arms race with no end in sight. But the real solution wasn't to shout louder over the noise, it was to stop using radio at all. The answer wasn't in the airwaves, it was in a beam of light. The principle is so elegant, it's almost deceptive. It's called total internal reflection. Think of the fiber optic core as a perfectly straight tunnel made of flawless mirrors. When you shine a light down one end, it doesn't just travel in a straight line. It bounces, ricocheting off the walls of the tunnel at such a shallow angle that 100% of the light is reflected inward, again and again, for miles. The light is trapped, a prisoner inside a channel of glass, with no way to escape. Now compare that to a radio signal. A 5.8 GHz radio frequency signal loses a huge amount of its power over just a single kilometer. It degrades, gets distorted, and can be easily drowned out. But a modern single-mode fiber cable? It loses as little as 0.2 decibels per kilometer. That is a near zero loss of information. It is the difference between a fading shout and a perfect, crystal clear whisper delivered directly to your ear. This isn't just a better signal, it is a fundamentally unbreakable connection. An umbilical cord of pure light immune to the electronic storm outside. But this creates a brutal physics problem. How do you attach a 20-kilometer-long physical string to a flying object without it snapping, snagging, or weighing down the drone? You can't just drag it. The tension would be immense. The solution is a masterpiece of mechanical engineering, the zero-tension spool. The drone doesn't pull the cable, it lays it. Like a spider spinning a web, the spool is designed to release the fiber with almost zero force, letting it unspool into the air and gently fall to the ground. It's an active, powered deployment system, a delicate dance of mechanics ensuring the drone feels no drag from the invisible thread it leaves in its wake. And this isn't just a simple glass thread. At its heart, the impossibly thin fiber core carrying the data. Wrapped around that, copper strands capable of sending power up to the drone, allowing it to stay on station indefinitely. And encasing it all, a jacket of aramid or Kevlar fibers, the same material used in body armor, giving this delicate glass strand the tensile strength of steel. It is a lifeline engineered to be weightless yet unbreakable. The idea isn't entirely new. For decades, wire-guided missiles like the TOW system used a similar principle. But shrinking that concept down to a reusable, high-bandwidth drone platform changes everything. A fiber optic drone is a ghost. It has no radio emissions. To electronic warfare systems that hunt for radio signals, it is completely invisible. It leaves no electronic footprint, allowing it to slip past the most advanced defenses deep into enemy territory. This creates the ultimate stealth platform. A drone can fly 20 kilometers, land on a hilltop, and become a silent high-definition overwatch post for days. feeding back a perfect uncompressed video stream. The grainy, static-filled feed of a conventional drone is replaced by an unshakable 4K view of the battlefield. But this godlike weapon is not without its flaws. The spool and fiber are heavy, cutting into the drone's payload and range compared to its RF counterparts. And while it's immune to electronic attack, it's profoundly vulnerable to a physical one. The entire counter-drone industry is now shifting. Instead of building bigger jammers, they're building nets, interceptor drones, and rapid-fire cannons designed to do one thing: physically sever that tiny glistening cable, a brutal low-tech solution to a high-tech problem. The fiber optic drone provides a fundamental truth. In the relentless cat-and-mouse game of military innovation, sometimes the most revolutionary leap forward comes not from adding more complexity, but by finding a simpler, more robust path, by trading the chaos of the open air for the perfect, silent certainty of a single strand of light. If you want to understand the tech that will define the next decade of conflict, subscribe and hit the bell. Is this low-tech approach the only way to beat the ghost drone, or will a new countermeasure emerge? Let me know your prediction below.